Hello, everyone. How's the weekend going on for you all? Hey, hey, I am super excited to have you all this weekend, and we are going to learn a lot of different things this weekend. So, super excited to have you all. Let us wait for a few more moments before all the folks join in, and then we'll get started with today's session, which is all about Docker containers and making sure that whatever project that you have built is deployed super smoothly to Google Cloud and anyone can access their application. Hey there, real lessons. You are hacking, and that is awesome. We all want you to build some awesome projects. And this month we have the month-long hackathon for the month of December. So I'm super excited to see all the projects that you have built throughout the month, and hopefully we'll get some cool projects from you all. So I'll wait for a minute more and then we can get started. In the meantime, you can let me know how is Christmas coming up for you all and also the New Year. And I'm super excited for it as well. We have some super cool Secret Santa thing going on in my office as well, and I'm super happy for that. So let me know how you all are feeling about the festive season. Cool. Okay, in the meantime, let me set up my screen. I'll add my slides to the screen. I hope you all can see the slides. Let me know if you are facing any difficulty in hearing me. I hope that I'm loud and clear and my screen is visible. But if you feel anything at any point of the stream, just let me know in the comments and I will be more than happy to address that. Okay, then we shall get started now. I guess everyone who comes along, I would like to thank them for being here in the stream. So today we will be learning about containers, what they are, even if you are a beginner or someone who might not have used Docker or any sort of containers before. I will be introducing you to that from the scratch. So Docker and everything. And then we will also set up a Google Cloud account and see how we can deploy our applications to Google Cloud with the help of Docker and containers. So are you all excited for that? I am. So let's get started. Give me a second, and there we go. So before we get started with the actual content, let me introduce myself. I am Sagar. I am coach at Major League Hacking, and I build DevOps solution professionally. I work for AWS partner company, so I work with them to build a solution. I'm a tech evangelist over there. And before we get started, I would like to wish you all a very happy New Year as well as Merry Christmas. So uh, I know it's like there is some time to Christmas and New Year, but I guess this will be my last stream for the 2023. So I would like to wish you that early in this itself. So, fun fact, if you don't know, I am from Nepal, and Nepal is currently in the year 2018. So we call ourselves from the future. So if you don't know, that's just a fun fact. We don't follow the uh, normal calendar, Georgian calendar. We have our own calendar, so we are in the year 2080. But for the rest of the folks from any part of the world, I would like to wish you all again a very happy new year. That's coming up in a few days. So you can connect with me on my socials as well. I'm very active on Instagram and Twitter, so you can connect me over there and message me if you want to learn more about the stuff that we do in the stream or anything else. So I'm happy to connect with you all. Now, again, I would like to welcome you all to what I call as the container lane. So whatever we are going to do is all revolving around Dockers and containers. So that's why I call this as the container lane. And I'm super happy to have you all here on the stream. And for following along this session, so please bookmark the specific link because it contains all the resources and the steps as well as certain code snippets as well as all the links that we are going to use in stream of today as well as the part two which will be held tomorrow. So this is a two-part series. The part one will be is being held now while the part two is scheduled for tomorrow. So all the resources for both the days are in the specific link. So make sure that you go ahead and bookmark this link. I'll just go ahead and type this in the comment as well so that you all can get the link and bookmark it for you all. So give me a second for that. bit.ly/containers-mls and yep. So please bookmark this. Real Legend says that they are from Ghana and Google Cloud is not working there whenever they are trying to sign up. I think that might be because of the credit card, or Google Cloud might have some restriction based on certain geographical locations. So, what you can do is follow the steps that I say in this stream. So, the fundamental technology that we are going to learn today about Dockers and containers is going to be applicable for whatever cloud provider that you might use in the future. I would be happy to check back if that works for your specific reason and get back to you after this stream. But even if you are not able to do that, please stay around, as the part one is mostly based around Dockers and containers. We are not going to do much in Google Cloud until the later part. So make sure that you just follow along and try to understand the concept. And then that will be applicable to other cloud provider as well. So no need to worry over there. Uh, and we have someone from Guatemala, if I'm correctly pronouncing that. Sorry if I have not. So welcome to the stream as well. And I will once again bookmark the resources link over here. So please go ahead and bookmark this page, because that contains all the resources as I already mentioned. So let's go ahead with the slides, and the breakdown of the two part that I mentioned is going to be like this. So the part one, that is what we are doing right now. So we are going to introduce Docker. We will learn some of the basic Docker commands and the use cases for those commands. We'll also be creating the Docker image. If these terms are not being familiar to you right now, please do not worry, as I'll be explaining what this means in the coming up time. And we will be creating Docker images for our own application. So we will be using a sample application, but if you even have your own application source code, you can containerize your application as well, and you don't necessarily have to use the sample application that I provide. And we will run the application locally using Docker this time. And finally, for the end of today, we will be publishing our image that we have built into Google Artifact Repository. So that is a service from Google Cloud where we can store all the images that we have built. And in the part two, we will be first setting up a database for our application, since I will be using a main stack-based application that will utilize Angular in their front end, MongoDB as the database, Express as the Node.js framework. So we'll be setting up Mongo Cloud and using Google Cloud, and then we will configure and run our containers on another Google Cloud service that is called as Cloud Run. So we'll be using Cloud Run to run our containers. And then finally, we will automate the deployment with the help of GitHub. We will push all of our source code to GitHub, so that whenever there is any change in our GitHub repository, uh, build process would be triggered, and then using the Docker file that we have mentioned in the GitHub repository, there will be a new Docker image built out of it, and then the Cloud Run service would use that new image to run our container. So we don't need to redeploy manually by logging into the console or through the CLI. That all happens automatically. And finally, we will learn about the best practices, and that will wrap up both of our sessions. So yeah, so we'll learn about Docker's containers, set up Cloud Run, push our images, set up database, and automate everything. So that's for the summary. So without any further ado, let's get started. So first, let us understand what Docker is, and before that, let us understand the need for it. So there is a term called as containers, and in order to understand the need for containers, we need to understand the application first. So any sort of application that you would build, whether you are building it for the month-long hackathon December, or for your college project, or if you are working somewhere, whatever you have built, it will contain some sort of code. It does not matter if you're using Python, JavaScript, or any other programming languages and framework. It will have some application code, and then it will need some runtime to run your application. So in the example that I've shown, I have taken a Node.js as the runtime environment. So Node.js is used to run JavaScript on the server side, if you don't know. And there might be other frameworks such as Django if you are working with Python, Laravel if you're working with PHP, or any sort of framework, Java, Kotlin, and all those things. So there will be a code, and then we will also have some runtime to run those and compile and run those code. And then there will also be some sort of packages and dependency that your application need. And this is likely for any sort of application that you would build, whether it's a Node.js project. You would most likely be using different APIs or third-party libraries and dependency. So in Node.js specifically, you have the npm package manager, but depending on the programming language and framework, you might have other dependency managers, such as Python has pip, as their dependency manager. Likewise, for Java, we have Maven and Gradle. So for Flutter, you might be using the pub package manager, so that it uses the Dart programming language. So what I mean to say here is that any sort of application will have the application code, their different runtime, the different code dependency manager, and all of these run on some sort of operating system on top of our operating system, right? So what we do is that we want to compile all of these dependencies and every sort of these thing that is needed to run an application into a single unit. And you might ask why? Why do we even need to have all of these in a single component? So that is because let's say I have been working on a Django project which is based on Python, and I have a specific version of Python installed on my machine. And when I want to share that with other developers or my friends, I can push that to a GitHub repository and they can clone that, right? But they might not have Python on their machine. So the first thing that they tend to do is to install Python. But even after that, they might run into issues running my application. That is because the Python in their machine, the version that it installed on their machine might not be the same which I am using. And sometimes when the versions of the languages or the framework do not match, applications tend to crash or they are not compatible with each other. So there are issues like this. So whenever you want to share your application code, you also have to make a proper documentation of what are the required tools, the specific versions. Also, there might be conflict among the versions of the dependency as well. So they need to install that as well. And all of this is a lot of hassle. So they need to install everything that I do. And next, let's say I have a Ruby application or a Java application. So even if I want to share that with other people, they need to have all of those installed on on their machine, right? And especially when you try to do this in production, when you actually build real application to serve customers or for your business purpose, what happens is that the server configuration might not match with your local configuration, whatever I'm using to build the application on my own PC. So that might not be the same as the server, right? So server might have a different operating system or the different version of different programming language, and things might not be same, right? So there is always this compatibility issue. And because of this sort of trouble, there is one popular phrase developers call, right? It's a very popular and fun phrase. It works on my machine, right? So developers always say it works on my machine, but the production people or the production managers, they always complain that the application does not run on the server, right? So Docker is here to solve that issue, because Docker, what it does is that it combines all of this into a single unit, which is known as the container image. Yeah, right. That is what you can see here in the middle of the slides. So we take the application code, we take the dependencies, we take the programming language itself and the underlying operating system, and we bundle it into a single unit, which is called as a container image. And this container image, once you build the container image, you can pass it to anywhere on the server or to other people. And in order to run this image or run the application, they just need one thing on their machine, and that is Docker. So if they have Docker installed on their machine, then Docker guarantees that the container image will always run the same way, no matter where it is being run. So that's a huge boost, and that is how Docker solves a huge problem. It compiles or bundles everything into one unit, and then with just Docker, you can run that container image uh, anywhere in the world or in any PC without the need to worry about the dependency, or without worrying that if that might not work on the server, because Docker guarantees that it will work. If it is running on your machine, that means that the Docker container will always work the same way on the server as well. That is a good question as well from Ethical Code. So every Docker container have its own installation like a virtual machine. Uh, I would say yes and no. But the one thing is for sure that if you just have Docker on your machine and you have the image will always run. Uh, there is a difference between a virtual machine and a container. And the major difference is that in virtual machine, when you create different virtual machine, each virtual machine will have its own operating system. So like our own PC boots up, the virtual machines also needs to boot up, the operating system inside it also need to boot up, and then once it boots up, it will then run the application, right? While on the containers, Docker uses the host operating system itself. So for managing the resources and the different Docker images, Docker do not rely on the base operating system that the image has. It uses the image. It uses the operating system of the host itself. But as you have said that there will always be a very thin layer of the operating system inside the image as well, and that thin layer is all that the application needs to run. So for the application, yes, whatever the application needs to run, the operating system layer will also be inside the image itself. But in order to, let's say, your Docker host might have 100 different Docker containers running, right? So for all of those, managing all of those resources and sharing the CPU, RAM, and all those things, it will rely on the host operating system as well. So that's a really good question, and I hope that I answer your question. Uh, it is definitely different from VM and containers since it utilizes the host operating system. It is spins up a lot faster as well. So yeah, so that is the superpower of containers. Uh, I hope that answers your question. So now let's move ahead. And now, as I already said, once you combine all of this, you get one single artifact or a component that is called as a Docker image or a container image. Please note that there are other solutions to containers as well. Docker is not the only solution, but Docker is what made it the most popular. Uh, okay, there is one good question. Another question. Let me just bring that up on the screen for you all. So Stoic Bark have asked, are the resources used from the host machine customizable by the user, or are they automatically configured by the Docker? And that's a really good question. So containers by default run in an isolated environment. So that means that whatever you do inside one of the container does not affect the other containers as well as the host because they are in the same in a separate space. It uses a separate isolation technique using namespace and C groups. Those are the Linux concepts, but just remember that containers are in a separate space. But since the Docker engine is itself running on the host, so definitely the CPU and the RAM as well as all the resources would be shared between the host as well as the containers, but they would be running in a separate logical space, so one would not affect the other. So your application running at the host would not affect the application running inside the container, and one container will also not affect the other container, just that the resources are being shared from the host to the containers. Yeah, so all the resources will be managed by the Docker engine itself. But in some scenario where you might need to provide certain access for the Docker containers to the host itself, so there are some privileged mode that the containers can get, and that way the containers can get access to the host itself. But that is also security threat. So whenever you do that, you need to be very careful. So mostly it would be configured by Docker, and you don't need to do it. But there are cases when you can customize it as well. And I hope that answers your questions. So let's go ahead. And I was talking about Docker. So Docker is once again an open source containerization platform. There are, as I already said, there were some other solutions, but Docker is what made containers popular and accessible to everyone. And then it also enables developers to bundle applications. As I already mentioned, whatever you have in your application, Docker enable you to bundle it into a single unit. And containers, like I said, existed before Docker, but Docker is what made it super popular. And it's a popular and the most preferred standardized way of shipping your application into production. Not even for production, I would say. It's used nowadays even for development scenario as well. Whenever you are working with a large number of people and you want to make sure that the application runs the same way everywhere with your colleagues and other developers, you just deploy a Docker image or at least include a Docker file in your source code so that the other developers can build the image and run the applications without the need to install all the dependencies and all those things. And like I said, Docker is super useful as it solves compatibility and dependency issue. It reduces a lot of setup time. You can quickly spin up different environment. You can sense in the production especially, you might have different environment for development, testing, and production. So with the help of Docker, you can do that very quickly. It's just a matter of few lines and commands that you can get the system up and running, as you would not need to install different programming language and framework again and again. You can install different process based on the operating system environment. And like I said, it's a universal way of deploying and running applications nowadays. And before we get into the Docker commands, I want to also highlight you about the Docker architecture. So first, the Docker architecture is divided into three different components. I would say that is overview. There are a lot of things going inside as well, but for getting started and to learn the basics, this is a good way. So first we have the Docker client. So this is an application that you install on your machine, and that is what allow us to run Docker commands from our terminal. So whenever we run Docker commands such as Docker run, Docker build, or Docker pull, so that is actually the Docker client, which will take all the requests and process it to pass it to the Docker host. And then on the middle, we have the Docker host, which actually contains the Docker engine itself. So Docker daemon is what contains the Docker engine. And the client send all the requests to the Docker host, and Docker host, the first component that takes on the client request is the Docker daemon. And you can also remember Docker host as the Docker server, because that will allow us to understand it easily. So the client and the server, the request from the client will be passed on to the Docker daemon, or you can also call it as Docker server. And based on the command, it will then forward the request to other processes, such as if you run the Docker command, it means that you want to run a container image. So it will use the image, whatever is there in the Docker machine. Or if it's not there, then it will try to pull the image from the registry, and then finally it will run the container. Same is the case for Docker build. It will the request will be passed on to the server, and then using the source code and all the other things, it will try to build the Docker images. And if you're just trying to pull the images, so pulling the image means that the image is not present in your machine and you are trying to get it from somewhere else. So let's say I am the developer and now I'm trying to send my Docker image to some of my friend, then my friend would need to pull that Docker images from a registry. And the registry that I'm talking about is right here in the right side. So you can remember it as a dog, similar to GitHub, where we store our code. So Docker Hub is the place where we store our Docker images. So once we have packaged our applications and made it into a Docker image, we will need some place to store that image, right? And that place is image registry. And by default, Docker Hub is the official image registry, but in this demo, we will also see some other image registry provided by different cloud vendors. So in this demo, we will see the Google Container Registry using the Google Artifact Hub. So that is specifically for the Google Cloud users, but we can use any of the Docker image registry. Please remember that by default, whenever you pull any images, it will use the Docker Hub as its image registry. So that is the high level overview of the Docker architecture. Please remember that we have the client, and then we also have the host. You can call it as a server, and then we have the image registry. And in most of the development environment, and also in the demo that we will do today, the client and the host are in the same machine. So both the Docker client and the Docker server will be installed on our own machine, and I'll show you how you can do that briefly. So let us go ahead, and now let us go ahead and start with the demo and learn about some of the basic commands. This is just the container lifecycle. I will just come back to this once we have the demo, but please note that we have this. Before that, I just want to make sure that everything is installed on our machine. So we'll come back to these commands. I will install all the requirement first, and then I will come back to this command. So let us go back and pull up my screen. Uh, Sorry about that. So the first thing that we need to do is to install Docker on our machine. So let us go ahead and do that. So first, let us go ahead and go to this specific website. Please note that all the links that I will be using today is mentioned in this specific document over here. And this document, as you can see, is already in the resources link that I've shared earlier. If not, if you're joining just now, then this is the link that contains all the resources, and it links to this Notion page. And I have mentioned all the links as well as all the commands. Not only that, also all the resources that we will be needing for part one and part two. So please make sure that you bookmark this Notion page, as whatever links that I'll be using today is already present over here. So make sure that you do that. I'll just zoom in so that you all can see over here. So we are going now through the prerequisites. So the first thing that we need to do is to download the Docker desktop. And I have already gone ahead and done that. So please go to the specific link over here. And depending on your operating system, whether it's Mac, Windows, or Linux, please download and install that. It's a pretty straightforward process. You don't need to do anything much. Just download and install that. And once you install this, what will happen is that you can open the Docker desktop. So I'm using the Mac operating system, so I'll be opening that and I will be showing you how it looks. Let me quickly pull that up. Just give me a second. Give me a second. So please go ahead and download that. If you're using Windows, please be careful that you might need to turn on the Windows feature for Hyper-V and the Hyper-V and the Windows virtualization platform. Please go to search and just search for Windows features, and there you get the option to turn on the Windows features. And from there, please select the Windows virtual machine platform as well as the Windows Hyper-V platform, because that might be needed depending on your system architecture. But if you're using Mac, you don't need to do that. Give me a second. I'm not sure why the Docker application is not being opened on my machine. Okay, so let me know if you are facing any installation issues while I debug my own. Give me a second. I think the Docker application is not open. It's not just displayed on my screen. I'll just quickly close my screen share and come back in a moment. Okay, give me a second. There you go. So it should be able to view now. So my Docker desktop is running. And let me quickly pull that up for you all. So there you go. So once you install the Docker desktop, you will be greeted with an interface like this. And you should also make sure that the Docker engine is up and running, and that you can confirm from the bottom left corner. Here you can see that the Docker engine is up and running. So that means that we are ready to run our Docker commands. So please go ahead and install the Docker desktop. And once you install that, you can run the Docker commands. Here you can see the containers list. Since I'm not running any containers at the moment, so it's empty. You can also see the different Docker images in my machine, the different Docker volumes and all those things. But since we are not running any containers, you are not seeing any of it. So let me open up my terminal and let me take this to full screen for now. So now we will start using the Docker command. Let me clear this for you all. And before that, let me quickly get you all back to the slides. And let us now see the Docker commands that I was talking earlier. Let me go to the pages. Yep, here you go. So before we learn the Docker commands, let's just try to see the basic Docker lifecycle. So whenever we talked about the application bundle, right, that we call as the container image. So the first thing that we do is create that image that we call as a container image or a Docker image, and we can start the container image, and it will then be shifted to the running phase or the running state, right? You can skip the creation and start process and directly run the Docker containers as well. So Docker container run is same as if you create a container and then start it. So it just combines two of these steps into a single step. You can pause your container if you want to stop the processes inside your application, and you can also unpause it. And then You can even stop your entire application itself. Let's say you want to save some of the resources from your host machine while you want to run other containers or do other things on your host, then you can start and stop your containers. And finally, once you are done with your container, you can even remove your container image entirely from your uh, host system as well, or your from your Docker host. So different phases of containers. So first we create the image and then we run the container. We can pause and unpause the container, as well as we can stop and start the container. And finally, we can remove the container. So you can see different commands over here. So Docker run, like I said, creates a container from an image. If you don't have an image and if you want to use someone else's image, then we use the Docker pull command. In order to start a container, we use the Docker start. Likewise, for to stop, to list all the images in our machine, we can use the Docker images command. And to list all the running container, we can use the Docker ps command. And to see all the containers, whether it is in the stopped or running state, we can use the Docker ps-a command. So let us understand this command one by one. Let me quickly pull back my terminal. And please, all of these commands are also in the resources link that I shared. So make sure that you go ahead and bookmark the resources if you have not already. So I'll put that up on the screen so that you all can always get that. So let me know if my terminal is big enough for you all, or if you want me to zoom in. I'll just zoom in so that you all can see properly. So the first thing that we can do is to get the information of our Docker system. So if you run the Docker info command like I did, you can see the client that I just showcased in the architecture, right? So the client is also installed here. You can see details about my client, the different versions, the different plugins that you don't need to understand right now. Uh, we also have server. You can see that it contains one container which is in the running stage. It has 5 images. You can see the storage driver and all those other things. Most importantly is the operating system. You can see that the operating system is the Docker desktop. Since we are installing Docker from the operating system, the total amount of CPU cores and the memory that the Docker can use. So you can see that Docker is actually installed on our own machine and it is using the operating system of our host itself. So that was about the Docker info command. Now, since let's say you all might not have any Docker images installed on your machine. So first, before we deploy our own application or understand how we can deploy our own application, let us try to use a public image and then see how we can run the Docker container. So before we do that, let me quickly pull up my browser again. Give me a second. And if I go over here and if you search for Docker Hub in Google, uh, it's the official image registry, right? Like I said, it contains all the images that you could get publicly, right? So in the Docker Hub, let me search for a very popular image which is used for testing purpose or also for production. But mostly when you learn something, we use the Nginx container because it is very lightweight and it's very easy to run and understandable as well. So this is one of the Docker image that is out there in the Docker Hub, and it is an official image from the Nginx team themselves. So I can use the Docker pull nginx command to get this image on my own machine. So that is what I'm going to do first. So I'll use the Docker pull nginx image. And you can see that by default, it is using the latest tag since we have not specified any version of the Nginx. So by default, whenever you pull any image without a tag, it will pull up the latest version. But any application or image can have multiple versions. So if you want to pull something with a specific version, you also need to provide tag. And we'll see how to do that in a second. So now that we have pulled the images, we can use the Docker images command to list the Docker images as well. And here, I can just so this to you all, you can see that in the Docker images, it lists up all the images in my machine. And there you go. The Nginx latest image, which we just pulled, is over here. But since I already pulled these images in my PC earlier, it uses the same image and list it over here. But if you're doing this for the first time, you should see the creation time as the latest time over here. So we pulled up the Docker images and you can see the image right over here, right? The next thing that I want to show you is how to pull certain images that has a specific version, right? So I showed you how you can pull the latest images, and that you can just do by doing this. But if you want to, let's say, pull a specific version of Nginx, then you can put a colon and then specify the tag over here. And you can see different versions of Nginx from the official site, and you can see the latest one is 1.25.3, but you can also get 1.24. the different versions of that specific one as well. So even in 1.24, we have the Pearl version, we have the Alpine one. So these are just the lightweight version of the image. And let us try to pull one specific one. So that will be 1.24. And you can see that it is now trying to pull the images from the Docker Hub, and it will be done in no time. So that is done. And again, if I do Docker images, here you can see that now we have three different one. One is the latest one, which is one latest version. We have the 1.25 as well as the 1.24. So you can see that we can pull different images from Docker Hub. So that I hope that is clear for you all. Let me clear that. Okay, so terminal looks good. Okay, thanks for that. This is just the normal terminal. I have just configured oh my ZSS in my terminal. I'm using, I believe, the default profile, and I'm also using Fig for all the autocompletion that you see. So that is how the terminal look like. So we have one question from Rasmi. So if we don't have our emails now, we can pull it from Docker Hub and use for purpose, right? Yep, exactly. Uh, so for the demo, when we will have our own sample application, we will be building our own Docker images. I will be providing the GitHub link for the sample code as well. But just for the demo that I want to show you the different Docker run command, you can just pull up the Nginx image from Docker Hub. Yep, and I hope that answers your questions, Rasmi. Okay, so that is done. So now let us try to run the container. Okay, so first I will do Docker PS, and you can see that right now I don't have any containers running in my machine, so that is why the list is empty. So let us run our first container, and for that, let us run the nginx image. And okay, so I'm now running the nginx image, and in order to if you just do this, let us see what happens. Okay, so you can see that the container has started, but it also occupies our terminal session. So that means that I can't do anything else from here, since the container in terminal session is being attached to my own Mac terminal, right? So in order to run the Nginx in the detached mode, what I can do it, I will clear this for a second. So what I will do is Docker run, and now I will use the dash D flag. So what this will do is it will run the Nginx content in the detached mode, and I can run other commands in my terminal as well. So here you can see that it displays one ID, and this is actually the container ID which is being run. And now I can type in the other Docker commands since the Nginx is running in the background or in the detached mode. Now, if I do Docker PS, here you can see that the container ID for the image that is being run, the image name, nginx, the entry point, and all those things. And the main thing that you can also notice is the container port itself. So it is saying that the container is running on port 80. And now, if I want to access the container from my web, since Nginx also has a web interface where we can get a basic detail about the Nginx container, what I can do is I can run the container in the detached mode, and I can also provide a port binding. So the container is running in its own isolated environment, right? Like I said, it is running inside an isolated process, so we can't access the Docker container directly from our host. I can quickly show you that. So since the container is running on port 80, so if it was directly running on my host, I should be able to access the Nginx container when I do localhost 80, right? But here you can see that the site is not being reached. That is because the container is running in a separate isolated environment. So normally, if we don't do any port mapping, we can't access the container directly. But if we do port binding, that means that we want to bind a specific port from the host to the port that the container is running, right? So since the container is running on port 80, so I want to, let's say, I could bind 80 to 80. So this means that the 80 port on host should be binded to the port 80 on container. But to make it distinguishable, let us do port 3080. Okay. So now if I run the Nginx container again, so this is the new image. This is the new container, and I can do Docker PS. Here you can see that it is being binded to port 3000. The port This is the host port, the first one on the left side. So that is the port on the host. It is being binded to port 80 on the container. And now if I go back to the browser and request port 3000, here you can see that we are getting the Nginx page, right? So that means that all the requests to localhost, that is my PC, on port 3000 is being forwarded to container on port 80. And that is how port mapping works in Docker. And that is very, very crucial to understand because we will be doing port mapping when we deploy our custom application as well. So please remember this. Got it. I hope that is clear. So we can access the application in this way. So we have pulled the Docker images. We have run the Docker image. We have also displayed all the running containers. We have also uh, run the application or the container in the detached mode. So now let us me go ahead and stop the container. And here to stop the container, you can copy the container ID or also use the name. You can see that the container is getting a random name, but you could also assign the name to the container using dash dash name option. But for now, we are just going to use the random name. And a very interesting fact about Docker is that you don't need to provide the full container ID. We can just type in the first letters of the container ID, and then it will automatically stop that. So for the first container 891, I'll just type in this, and you can see that it has stopped. Now, if I do Docker PS again, you can see only one of the container is running, right? So let me stop that as well. Docker stop CAD, and that this will stop that as well. And now we don't have any container. So that is all done. And I hope that explained the basic commands for Docker. And we have learned the very basics of Docker. Uh, we have learned the command to pull the Docker images, run, start, as well as stop. If you want to see all the containers that is start as well as in the stop state, you can do that using the Docker ps-a option, and here it will list all the container whether it is in the running or stopped state. And since all of them were stopped, you can see that the status was exited for all of these three containers. So now let me go ahead with the session. I will clear all of that for now. And if you want to delete images, I want to quickly show you that command as well. So the command to list all the images was Docker images, right? But if you want to delete, let's say one of the images, let's remove the Nginx 1.24 versions. Okay. So the command is Docker RMI. So Docker RM was for container, whereas for Docker images, it's RMI. And then we can pass in the uh, image name, and we also need to pass in the specific version. So if the tag is latest, you don't need to pass in any tag, but if it's using certain tag, then we need to pass that as well. So this will remove the Docker image version 1.24 from our machine. So now if I do Docker images again, I should not be able to see the Nginx with that version. And there you go, we only have the two other Nginx versions. So there we go. Uh, we have a very interesting question as well. So MEIS, if I have that pronounced that correctly, just got here and want to know what's this line about. So hey there, we are discussing about Dockers and containers right now, and we are just going through some of the basic Docker commands. We just went through the installation process, and then now we are learning some of the basic commands. So after this, we will deploy, and we will try to deploy our application to Google Cloud. But before that, we are trying to containerize it using Docker. And once we do that, we will be able to make our deployment process a lot easier. And then we will be able to deploy that to Google Cloud in the second part, which will happen tomorrow. So you're not too late. I would like to highlight though that there is a very specific link which I will provide in the stream. So please go ahead and go through the resources link over here, as it contains all the resources, prerequisites, and the steps that we are carrying on in a Notion document. So even if you have just caught up right now, you will be able to catch up with everything that we did uh, till now in that document itself. So do not worry. You can also rewatch the recording. This will be on YouTube and Twitch, so you can rewatch it as well. Also, you can follow the document. So you're not too late if you are joining right now as well. Cool. So we have seen the basic commands for Docker, and now let us try to containerize our own application. So for that, I have created a repository. So let me quickly pull up my document over here. Mm, Give me a second. So this is the resource document that I was talking you all about. So we have completed all the Docker commands as of now. And now let us try to clone the repository. So this is the sample repository that I made. And you should all be able to get this repository on your machine. Please make sure that you have Git installed on your machine. If you have not, I have mentioned the link where you can install Git on your machine in the prerequisites part of the page itself. So if you go over here, here you get the demo prerequisites. Here you get all the tools and the things that we need to install to get completed with the system. So here you go. What I will do is I will get this Docker, this source code from GitHub to my own machine. So let me go ahead and do that. I'll open the terminal again and let me go inside the MLS folder. So you can use the git clone command whenever you want to pull GitHub source code repository. So let go ahead and do that. So this will clone the uh, repository into your machine. But if I do ls, you can see that the application is already cloned in my machine, so it will not clone that again. So that is why it was failed. But if you're doing this for the first time, it will clone that into your machine and you will be able to get the application code over here. And now let me go to the application code. So that is Node.js, SQLite, Docker, and I will open the VS Code over here. And if you have installed VS Code, you can just uh, use the shortcut of code space dot to open VS Code from that directory. Otherwise, you could just open VS Code normally and navigate to this folder. So sorry about that. Uh, I don't know why is my keyboard misbehaving today. Okay, so I'll just open the VS Code over here, and there you go. Let me know if you can see the uh, screen clearly. Cool. So let us just try to understand what is here in this repository. Let me minimize all of these. Please note that you do not need to understand any of the application code that is displayed in my screen right now. I just want to make sure that you will understand the concept of Docker so that you can do this for your own application. So this is a Node.js application, and for those of you who do not know about it, Node.js allow us to run JavaScript on the backend or server side, and it is very popular whenever you are working or trying to create a backend solution, especially for React or JavaScript based frameworks such as React, Vue.js, and all those things. So it's normally paired up with the Express framework, which runs on Node.js. So this is a Node.js framework based application, and let us try to see what the application has. So if you go to the source code of the application repository, you can see different routes over here. So that's items and items with specific ID, and you get all the get, post, put, and delete, or the CRUD routes, right? So this is a to-do application for those of you who do not know. And now let us see the power of Docker. Okay, so now, as I said you all that Docker makes it easy to build everything into one single unit, right? So here we have the source code, right? We talked about this earlier. Then let us try to see the dependency that the application needs. And in case of JavaScript or Node.js, the dependency are listed in a specific file called as package.json. If you're using it for Django, it could be, or a Python-based application, it could be in requirements.txt, right? So based on your specific framework or the cool, I'll just try to zoom a bit more. So based on specific framework or technology that you're using, every framework will have a specific package or dependency file. So for in order to build our Docker image, so the first thing that we need is the source code, which we already have in this repo. The next thing that we need to have is the package file, which we also have here. Now, please note that I do not have Node installed on my machine, or I do not need to have it because I'm using Docker, right? So I can just create everything from Docker itself. I do not need to have Node.js or all of these dependencies installed on my own machine. And then the next thing that we will need to build our Docker images is the Docker file. And this file is super important. So every time you need to containerize your own application, you would do that with the help of a Docker file. And this is a very specific standard and format. You cannot name this file as anything apart from Docker file. And if you do so, you need to provide the specific file name during the Docker build command as well. By default, it is a very good practice that you name your Docker file as Docker file, and you can see that it starts with capital D and not lowercase d. It starts with an uppercase T. So that is a standard format. But if you are writing your file name as anything apart from this, then you need to mention the file name during the build command as well. Cool. So let us try to see how the Docker file works. So first we have mentioned the version of the Docker file. This is completely optional. You do not need to write these. I just want to make sure that this specific Docker file follows the Docker syntax version number 1. So this is optional. This is commented out. You don't need to worry about this. And sorry about that. Give me a second. Okay. So the line that you see over here, so we have about one, two, three, four, five, six lines of commands right here, right? And all of these is a specific layer in the Docker image. So whenever you build the Docker images, that it builds it in form of layers, right? So the topmost layer will be the topmost line will be the bottom of or the base of your image layer, and then the next instruction will be on top of the earlier layer. So that way it will carry on. So that means that the final command that we have over here will be on the top of the Docker image layer. So just remember that Docker image works on layers. So whatever comes at the front will be on the bottom of the image layer, while whatever comes at the last of the Docker file will be on the top of the Docker image layer. So just please remember that. So I mentioned you that Docker container image will also have a thin layer of operating system that is enough for it to run the application, right? And in the first line, we are doing exactly that. So we are taking the node. We are taking the node framework and we are using the version 18 of that node application or the node framework, I would say. So you can check the different versions of your framework that is available on Docker Hub. For Node, we still use the 18, but I am pretty sure that Node also have version 20 released. But for this specific demo, we are using the Node version 18, and it is based on the Alpine version. And for those of you who do not know, Alpine is a lightweight flavor of Linux operating system. So most of the Docker images in their first line would have some sort of Linux flavored uh, Alpine image or any other image, but it will mostly be on Linux. So you might be able to see Windows-based containers as well, but mostly in production we run the Linux flavored operating system. So the first line specifies that the Docker image should have Alpine based Linux, and it should also have the Node version 18 installed on it. And you can get this from the official Docker Hub repository. I'm not writing this on my own wheel. I searched for Node.js images on Docker Hub, and from there I just used the base image for Node.js using the Alpine version from there. So this is a specific tag you can get on Docker Hub. After that, I'm setting a work directory of slash application, and this is a directory inside the container image. So you can see that I am right now in the Node.js SQLite directory in my own machine, right? So we have this specific route, but this is on my host. Inside the container, it will have its own Linux operating system, right? Or the specific file system. And this is the file system inside the container, not on my own machine. I do not have slash app on my PC. It is the directory that will be created inside the container. And then on the next step, we are copying the dependency file package.json as well as the yarn.log, which is again another dependency management file inside the slash app file. So since we have already set the working directory to slash app inside the container, so dot slash here will copy that to the slash app itself. So if we have not set this, let's say if it was like this, then I would have to provide the full path such as slash app. This would have been the way to do. But since I have already set the work directory, I don't need to type in the full path here. Whatever we run here will be done inside the slash app folder. So that is inside the container. And once we copy the dependency, we are installing all the dependency using the yarn package manager. So in the slides, I showed you the npm package manager, right, for Node. But here I'm using the yarn package manager, which is also another package manager for Node.js. And I'm installing all the dependency using the yarn install command. This might be different if you're using a different framework, let's say Python or Ruby or Laravel. And once I install all the packages, so remember that container now has my dependency file, the Node.js installed on the Alpine based flavor. So it has the operating system, it has Node installed on it, it has the dependency file, but it does not have my application source code, right? So we also need to copy the application source code, and that is what we are doing in the line number 7. So this is the source. First dot specifies the source. So whatever there is in the directory or the path where the Docker file is stored, right? So Docker file here you can see is in the root of this folder, right inside the Node.js SQLite Docker folder. So whatever is in this folder will be copied inside the container. So this is the source image and this is the destination path. So the source is always from host while the destination will always be on container. So this means that now inside the container there is a slash app folder, and that slash app folder contains the package.json, and then we installed all the dependencies. In Node, it would be Node module. So Node module, I don't have it on my source, but on the host. But inside the container, we also have the package installed in Node modules, and then we are copying the rest of the source code inside the container. So now my container has everything that it needs to run, right? But we also need to give it a start command, and that we have done in the last line. So here you can see that we have given the start command node src says index.js. It could be Python main.py for a Python-based application or anything depending on your specific framework. And that is how you build a Docker image. So please remember that Docker file or Docker works on layers, and each line in a Docker file represents one layer. First, we get the node installed on the Alpine-based image inside our container. Then we set up a working directory. Then we copied the dependency file inside the container, and then we install the dependency. So now our application has all those things except for the source code. So then we copied the source code, and we also have the command to run the container. So we have everything that we now need to build the Docker images. So inside the terminal of VS Code, let me build the Docker image. And for that, we use the Docker build command. Sorry about that. And let us give it the tag. So like I said, every Docker image have a tag, right? So if you do not use a tag, it will use the default tag. But if you give it a tag, then it will use the specific tag. Okay, so let me give it a tag, and I will call this as Node.js to do. Uh, and let me give you the specific tag. So the image will be named as Node.js to do, and the tag will be 1.0. That, let's say that's the version of my application, and I will need to provide it a path where the Docker file is stored. Since the Docker file is right inside the Node.js SQLite Docker, so I am already inside it, so I can just use the dot as the path of the Docker file. While if we are running this from a different path, then you would have to give it a full path. But I can do this, and now it will build the image. You can see that it is being built, and like I said, each line will be built one after the another. So you can see this was the first layer, then the other layer are over here, and you can see that three of these layers were cached since I already ran this command earlier before the demo. But if you're doing this for the first time, this will not be cached. And caching is another very important and efficient way how Docker keeps up your build time very fast, since everything is a layer. So next time whenever you build the Docker images, if nothing has changed in that layer, then it will just use it from the cache. So the build process is a lot faster. Cool. So let us try to see the images over here. So, let me clear this up. And now let us see the images that we built and see if we have the images right here. Here you can see that we have the Node.js to-do image that we just built. The size of the image is 221 MB. And you can see that it was created 45 seconds ago. We also have the image ID over here. So that means that our image was successfully built. And now we can run the container from the image. So let us go ahead and do that. Let me clear this up, and now I can run the image like I would normally do, and I will use the run command. I will also run it on detach mode since this is a web application, and since the Node.js application here runs on port 3000. So how I know that? Because I built this application. So inside index.js, if you go over here, you will be able to get the application port right over here. So you can see that the application is listed on port 3000. Normally, you can also see that in many Docker file, many developer or the DevOps people expose the port explicitly in the Docker file as well, so that uh, the people do not need to go inside the source code and see that. So that is a very common pattern that you could see as well. So I will again do a port binding that we discussed earlier. So I will bind the port 3000 of my host to the 3000 port of the container, and I'll just run this image. So the image name was uh, Node.js to do, and then I'll run this image. So let me do that just a second. So that is an error because we forgot to give the tag version, right? So we also specified the tag as 1.0. So we need to do that. And now you can see that the container is running. I can do docker ps to confirm that. You can see that the container is running, right? So since the container is running now, let me go back to the uh, browser and check that out. Now, if I go to localhost 3000, here you can see that the container is running and I can get my to-do application right here, right? So this will be to-do one. I can add more details. Behind the scene, it is using a simple SQLite database to store all this uh, data, right? So buy groceries and all those things. So I can do all of these. This is just a simple to-do application. I can delete them, I can add them, and I can do also all sort of things. So we built our container image right here, right? So now how can we deploy this to Google Cloud? So let us go ahead and do that. Uh, Now, I think we have covered a lot of different things that we need to do over here. I just wanted to show you a couple of more things. So I showed you an example for uh, Docker Node.js application, but let us try to see how uh, it look like on the other applications as well. So if you go to the Docker samples that I have mentioned in the reference, you can see that the samples have a lot of different applications using C Sharp, using Rust, using Go. So you can check out the uh, Docker file for this specific application as well. You can find more on the awesome compose, which I really like because it has almost all sort of application use. Let's check out for the Django application. So here you can get a sample Django application, and inside the application, you will be able to see the Docker file. So this is how uh, a Docker file would look like for a Django application. The similar thing that we did earlier. So we are taking the Python 3.7 Alpine version. We are exposing a port. We are setting a work directory. We are copying the requirement.txt file, and then we are installing the Python packages using pip3 and just starting the command, right? And then this is the multi-part stage that we don't need to know right now, but you can get samples of different frameworks such as Django, Fast API, and a lot of other things in here itself for React applications as well, Java and Vue.js as well. So that is how you can do that. Let us see some questions that we have. So first we have question from Rasmi, the difference between uh, copy dot dirt. Okay. So copy, so I'll explain it from here itself. So the first path, the first thing on the left where after you write the copy command is the destination. So dot here represents the build context where you are running this Docker file. So let me quickly go back to my VS Code. So since I'm writing dot, that means that the path where the Docker file is command, and since Docker file is contained in this Node.js SQLite directory, it will copy all the thing that is inside the Node.js folder inside the dot. Again, dot here represents the path inside container. So left one is for host and the right one is for container. So whatever there is uh, inside this folder where the Docker file is located, it should be copied to the directory inside the container. But since we already set the directory as slash app in the line number 4, so this will be copied inside the slash app directory of the container. And I hope that makes things clear. So remember that this on the left is for the host, and this on the right, and the dot on the right is for the container. And then we have another question. Can I install Docker MySQL image and connect it with the backend server so that I don't need to pay for a database service? Okay. Ye- I would say yes, but you should not do that. That is because you can definitely install Docker on your own PC, and then you can connect it with the backend server. So that would be totally be working, but you will be you need to do some additional networking and storage configuration. So you need the data to persist, right? So there are advanced concepts of that Docker volumes, which will allow you to store the data persistently. Because right now, if I remove the container and I start the container again, the to-do list that we created inside the application would be gone because containers or Docker by default do not preserve data. It will wipe out those. But there are advanced concepts like Docker volume, which will allow us to mount a specific path inside our host machine, that is my PC, to the container. And that way we will be able to purchase our data. But if you're using this for the production workload, that means that you need your PC to be up and running 24 by 7, and that you also need to make sure that you have enough storage and enough capacity that your PC can run that container. So yes, that is possible, but that is not something you should do for your production workload. But if you're just learning and doing it for development, then that is totally fine, and you could do that as well. Definitely, you should be able to do that. But we'll again check see when we use the Google Cloud and MongoDB how you can do it for free as well, because they do offer some of the generous tiers in running our database on production as well. So you could be able to get away it in a cheap or almost no cost. So please watch out for those. We will cover the database and all those things in the later stage as well. Cool. So right now we learned about Docker. We saw the different basic Docker commands. We saw how we can pull the different images from Docker Hub and run in a detached mode. We saw about port bindings. We also saw about how we can containerize our own application using Docker files. And then we saw how to build the Docker images and run it locally, right? So that is all done. So now let us just get ready for the part two that will be scheduled tomorrow, and we will be setting up a Google account for it, and we will also try to at least push one of the images that we need for the second demo so that we are all ready for tomorrow's session. So let me go ahead and do that. So the first thing that you need to do, yeah, that all need to do is to sign up for a Google Cloud account. So I have mentioned the link in the resources section as well. So please go ahead and uh, uh, create a Google account from that link. I'll show you the step over here. So sign up for the Google Cloud account, and since I have already created an account, it will directly log me in into the cloud console. But if you are doing this for the first time, it will ask you to sign up and make sure that you set up a billing account as well. Please note that it will require you to have a credit card to sign up for the account, but you will not be charged until the $300 credit expires. So when you sign up for the first time using a valid credit card, you will get free 300 Google Cloud credit, and that is more than enough to complete whatever we do at this workshop, and also for you to learn a lot after the workshop as well, because that is a sufficient amount for development and learning. So you'll not be charged at all, but please keep an eye on that remaining credit section, because in the future, if you just forget to clean up your resources, or if you spin up huge number of resources, so that credit might run out, and it will then charge your actual credit card for the amount. So please be careful with the remaining credit section. So once you go ahead and sign up for the Google Cloud, go to the console, and the console link is console.cloud.google.com. I've also mentioned the link in the resources itself. So please go ahead and open up the console, and the first thing that you need to do after opening up the console is to create a project. So let us go ahead and create a Google Cloud project. So I've already created a project called as MLS Stream, but if you're doing this for the first time, please go ahead and create a new project. You can name it whatever you want. Uh, my awesome project. I would name it that way. You don't need to select any organization. If you are working with certain companies, then you can select the organization location over here, but you don't need to do that. The project name is set, and now I can create resources inside that project once the project is created. So the project is created. Here you can see, and you can select that project, and you can see the project that you are currently working on right here in the top bar. So I'll switch back to the MLS stream project, but you can select whatever project you have just created. And you can see the project number, the project ID, and all those things right over here. And the first thing that we need to do is to um, create enable some of the APIs. So I would recommend you to go to the APIs and services section, you know, and then click on enable APIs and services. And after that, uh, I would request you to at least enable the artifact registry API. So if you search for artifact, then you'll be able to see the artifact registry API. And like Docker Hub, I already showcased you all the Docker Hub, right? So this is the official registry from Docker, which provides us all the public images. We could also sign up for Docker Hub and then push our own images to Docker Hub and use this for the demo. But Docker Hub only allows us to have one private repository by default. So if we are working in multiple projects, then we will not be able to create private repositories. You might be good with just using published repositories, but there are cases where you don't want to share the Docker images to public and you just want to restrict it to your friends or your colleagues, then we will need to store it in a private repository. And that's why we're using the Google Cloud, because Google Cloud allows us to create private repository so that just our applications or our friends and people who might need access to our Docker images can use it. So artifact registry is what allows us to store these images in Google Cloud. There is also Google Container Registry, but Google Container Registry is now being deprecated, and Artifact Registry is the new version of it. So we all, and I would also recommend you to use the Artifact Registry instead of the Google Container Registry to store our images. So go ahead and please enable that. I might have already enabled that, which looks like I don't. So I will enable this Artifact Registry API for now. So let us wait for this. Just a second. I guess I am signed up using the other Google account. So I'll just come switch back my account and show you all that. Give me a second. I'll switch to MLS account. And now if I go to console.cloud.google.com, here, uh, if I go to the APIs and services, and I can search for registry, uh, artifact registry, and here I should be able to see that. It should be enabled because looks like I was logged in from another account in the other console that I showed you. So here you can see that, right? The API is already enabled, and I also have a sample repository that I created earlier. So this is the repository. Once we enable it, you will be able to access the repository right over here. Let me just zoom this for you. You can see that I have one repository where I have the Django sample application image, which was for the other use case. This is not for this demo. Plus, please remember that this is how the artifact registry would look like. So please make sure that you enable the artifact registry API, and then we should be able to good to go. The next thing that I all want all of you to do is to clone a mean stack application. So I don't mean MEAN mean, I meant the MERN, Express, Angular, and Node.js framework. So that is in short called as mean framework. So what we will be doing is that we will be deploying a full-fledged mean application. So that replicates a real-world application, right? Where you would have a front end made with React, Angular, or the framework. In this case, we are using Angular. And then on the backend, we will have Express or any other Node.js framework. It could be Django or Laravel or anything. And then we also have a database with MongoDB. So that explains or showcase like a total scenario. So we'll be using that sample application and we'll be deploying that to Google Cloud using containers. So let me go ahead and clone that. So we have completed all of this. And if you go to the resources section, I have mentioned the mean stack application link as well. So please go ahead and clone this repository. I'll just also post it in the comments so that you all can see that. So please go ahead and clone this repository on your own machine. I have already done that. So let me quickly showcase that. I will just showcase one back, and here you can see that I have already cloned the mean stack application. So I will cd into the mean stack application, and I will open the application in VS Code. So here you can see that, let me close and minimize all of that. Okay, cool. So here you can see that this is a mean stack application. So you will have a client, and this is a Angular application. So inside the app, inside the // app, you can see all the TypeScript that is being used for Angular. You can see all the assets that the application might need, the different environments, the index HTML file, and all those things. So we don't need to understand code at all to deploy this application. This might be your own code as well. So this is the client, and for the client, we have our own Docker file, right? So This is an Angular project, so it has its own Docker file. And likewise, we have the server. So server is very similar to the Node.js Studio application that we saw earlier. So it also has the source code over here. Again, it is using the TypeScript as the language and not JavaScript. TypeScript is just a superset of JavaScript, and it's a more advanced one. So please do not worry about the programming language or the code over here. I will explain the concepts related to Docker. So please stick with me. So we saw the client, and now we also can see the server over here. And here you can see the Docker file for the server as well, right? And if you see this Docker file closely, it is very similar to the Docker file that we saw for our Node.js application. So for first, we are using the base image for Node.js. It's using the Node.js version 17. We are setting up a work directory. In the demo that we saw earlier, we were using the slash app directory. Here we are using the slash user slash app directory. We are again copying the package.json. We are installing the dependency. Earlier we used yar. Now we are using the npm package manager, and then we are copying all the source code, right? So since this Docker file is inside. So if you see the path of the Docker file, it is inside the server directory, right? So the Docker file is inside the server directory. So this copy means the dot here signifies all the files in the same level as the Docker file. So it will copy all the things that is inside the server directory. And if you remember, it will copy it inside the work directory that was set above. So it will copy everything inside slash user slash app inside the container. So from the host to the container, and then we run the npm run build command that will start the that will build the TypeScript files, and then we will start this server using node test slash server.js. So it will precompile this application into test folder, and then once we have the precompiled version, we can run the application using the node command node and the name of the server files this slash server.js, and that will run our application. So that is for the client, as that is for the server, and that is and we also can see a similar Docker file for the client as well, right? So first we are installing uh, we are using the Node.js 17 version here as well. This is an Angular based application, and here you can see that this is a slightly different Docker file than we saw earlier. If you see two from statement in the same Docker file, please note that it is using a multi-stage build, and uh, let us forget about this for a second. Okay, I'll just cancel it over here and just see the first part. So we are again setting the work directory. We are copying the package.json. We are installing the dependency. We are copying everything else. So from if you see the Docker file is inside the src folder inside client. So it will copy everything over here from here inside the working directory of the container, and then it will run the npm run build command. And for most of the front end framework like Angular, all the things that it will build will be packaged, since React or Angular or all of those things ultimately produce the static files, right? The HTML, CSS, and JavaScript that our browser can understand. Since they are the front end framework, they will always produce these files, and it will not have the server side logic or something that needs to be run 24 by 7. It can simply be represented in HTML, CSS, and JavaScript. So it will build those. So npm run build command will do that for the front end framework such as React or Angular. So I can verify that, and I can show you that using package.json. So if I go to npm run build, you can see that it is using the ng build command behind the scene, and ng build command is the command to build the Angular project. So Dockerfile will build the Angular project, and whatever the output will be produced from here, right? So there will be an output which will be produced after we run the npm build command. We don't need to run this command locally. That's the power of Docker, right? So if I did not have Docker, and if I were to deploy this application, I would have to install Node on the server. I would also have to install Angular. I would have to run all of these commands by myself by uh, getting the access to the server, whether it could be through SSH or through the console. So I would have to do all of these. But now I'm writing all the instructions in the Docker file, and it is using that instruction to package it into a container. So it is using the npm run build, and there will be an output. And whatever the output is there, now I'll bring back the other part. So this output will be input for the next instructions, right? So this is called as multi-stage build. So first we build a Docker image from this specific lies, and then whatever is built from there, we can use that output as an input to the next stage. So in this stage, we are using the Nginx image, and Nginx, if you don't know, it is used to either solve static applications, mostly used in production to solve static content, or uh, act as a load balancer, or even act as a reverse proxy. And in this case, we are using it as a reverse proxy, and also to solve our static content, whatever is built from this stage. And we are copying a basic Nginx configuration, which is right over here inside the configuration path of the container. And if you see, we have the copy from build, right? And this, since we named the first stage as build, it will copy whatever was built from this stage. So once you run the npm build command, there will be one dist/client folder which will be created inside the src folder. So that would have been created if I were to run this locally, run this command locally, but that Docker will do that automatically for us. So it will copy whatever that folder contains inside the nginx/html folder, and nginx uses this specific folder to store the static content. And that means that whatever the static file that was produced from the nginx build, sorry, the angular build command, it will be inside this folder. And since this folder is now being copied to the html folder inside the nginx folder, now the nginx has all the static files that it can use to solve the static content. And finally, we run the nginx command globally, and it is running in the detached mode. So we need to give this flags, and you will be able to run the container. So note that we have two different Docker file, one for the client and likewise for the server. So that means that we will have two different Docker images, right? Uh, locally, when we run this, uh, locally, if we run these containers, we would be able to uh, we'll be able to run the application and see it on our machine. But but since we are trying to deploy this to Google Cloud, we would need to push these images to Docker Hub, right? So let us go ahead and do that. I would not run this application in my own PC, because that does not make much sense since I want to deploy this to the container. So remember that we need to create two different Docker images. Now we have the Docker images for both client and server. So we'll just build the Docker images for both client and server, and then we'll deploy this to Google Cloud using Google Artifact Repository. And then there is another service called as Google Cloud Run, which we will explore tomorrow in the second session, and that will actually run our containers. So Artifact Repository stores our Docker images, and Cloud Run will allow us to run those containers. But you might be wondering, how does the client communicate with the server, right? So if this was running locally, we could just use the port to access the server. But if we are doing this for the Google Cloud Run, we would need the specific URL that we will see tomorrow. So do not worry about that. Let me now try to go to the server, as I want to first containerize the server. So I will go to the server, and here I have the Docker file, right? So I will use the Docker build command, Docker build -t, and this will be mean, I would say, as towards a as server. Let us give it a tag of 1.0, and the Docker file is inside the server folder itself. So I am just mentioning the build context as dot, and this will build the Docker image for me. So while this is being built, let us go back to artifact repository, dot that account, specifically this account, and create a repository to store our applications. Okay, so let us go ahead and create a new repository, and I will name this as mean application. The format would be Docker, since I will be using Docker to deploy our applications. Let us select the region, and for the region, here explains the or states the data center that the Google Cloud will use to store all of our artifacts. So please select the region whichever is near to you. Since I am based in Nepal and there is no data center in Nepal, so I'll select the data center from India, since that is closest to me. So I'll select the Mumbai one. You can give it a description or not. So let's say if you are from the US, then you could choose the US region as well. Uh, so encryption, and I will leave all of this by default and create a repository. So this will just take a moment. Let us wait for it, and that should be done in no time. In the meantime, let us check if the image was built properly or not. Let me go to VS Code, and you can see that the image is built. So I can do the Docker images to verify that. And here you can see that if you have the mean Node.js server with tag 1.0 already created 26 seconds ago, and the size is 380 MB. So that means that the Docker image for our server is now created. So remember that the Docker image for our client is still remaining. We will do that in a moment. Let me go back, and you can see that the Docker the bean application repository is now created. So I'll just go inside the repository, and now I can see the setup instructions. So you can see that we need to in order to push images to the Google Artifact repository, we need to authenticate our terminal or our PC with the Google Cloud itself, right? Uh, so for that, we have the gcloud auth command. But before we use the Google Cloud auth command, we need to install the Google Cloud SDK. So please go ahead and install the Google Cloud SDK in your PC if you have not done that. The link for installing the Google Cloud repository is right here in the prerequisites section. You can see that I have posted a link from where you can install the SDK. So if you scroll here, you can see that you can install it for Linux. You can just download the zip file. You can extract it, and then you need to run a shell script, which I will just showcase to you all, and then you should be able to run the zcloud commands, and that means that Google Cloud SDK is installed. For Windows, it's the Google Cloud installer. It is a exe file, so just download it and install that. For macOS, which I will showcase you all, you need to download the zip file first, which I have already done. Let me just quickly pull my terminal, and here you can see that I already have the zip file over here, which I already extracted. And once you extract it, you will see the Google Cloud SDK folder. So let me go to the Google Cloud SDK folder, and let me clear this up. And now if I list all the things, here you can see there is an installation script. And what you can do is you can just inside the Google SDK folder, you can go, you can write dot slash and then install dot sh, and this will install the Google Cloud SDK on your machine. Since I have already installed this, I do not need to do this again. But if you're doing this for the first time, please make sure that you run the installation script. If you are doing this for Windows operating system, you do not need to run the installation script, as you get an installer file that you can just run and and it will be ready to use for you all. So that is done. And once you run the installation script, you should be able to run the zcloud command. So let me go back to the MLS folder. And now if I do gcloud, you should be able to see some output over here. And here you go. You can see different outputs. So that means that the Google Cloud is installed. And for the first time, when you install the Google Cloud SDK, you need to do the Google Cloud init command. So this will initialize every settings and configuration that you might need. So you can see that I have already initialized a configuration. But if you're doing this for the first time, please follow the instruction on the terminal. It will redirect you to the Google Cloud on your browser, and you just need to allow the permissions. Just click on allow, and then you will be redirected back to the terminal. After that, you need to select the project that you are working. You can see that I've already selected the MLS stream containers as the project, and the default region is set to US West 1. Please note that even if you set the default region as US West 1, you can still perform actions in other regions. Like I am storing the artifact in the Mumbai region as well, right? So that is AP South 1. I can still do that. That is not a matter of concern. So to showcase you how the steps look like, I will showcase you all the command. Let me do that again. So I will create a new configuration. This is a test configuration. You can give it whatever the name you want. It will perform some basic network check. Sorry if my nose and sound is being changed. That is because I guess uh, I'm getting some sore throat. So sorry about that. And it will ask you to use the account that it will use for the configuration. Since I already logged in from the browser, so it will display my email over here. But uh, for the first time, you will need to log in with a new account. So I'll showcase you that as well. So that is why I'm selecting two. And here you will be able to select the account that is associated with your Google Cloud, and make sure that you select that account and allow all the permissions, and uh, you will be able to initialize the project. So I'll click on this. I will allow, and now you are authenticated with Google Cloud CLI, right? So if you go back, then you are already authenticated, and you will be able to work with different projects, right? So I'll again select the project that we created, that was MLS stream containers, that is on number 2. So I'll click on that, and here we go. And now if I run gcloud init again, you can see that it is now working on the MLS streamers containers project, right? So that is all set. I don't want to do anything else. So that means that gcloud is configured properly. So I can go back to the uh, artifact registry, and I can copy the command that will allow my terminal to authenticate with the Google Cloud Artifact registry. So I will go ahead and copy this command. So it will use the command to authenticate the terminal from my Mac to the Artifact registry hub. So I'll just click on yes, and you can see that the Docker configuration file is updated, and it is now authenticated with the Google Cloud registry or the Artifact Hub registry. So we are now almost ready to push our images. So before that, there is some requirement that Google Cloud or any other cloud provider for that matter, whether it be AWS or Azure, required you to uh, tag your image in a specific format before you can push that image to the artifact registry, right? So let me go ahead and do that. And before that, I can show you the format. So right now, if I show you the images, I can show you that quickly. I can do the Docker images, right? So you can see that the image is quickly. Sorry for that. Let me zoom that. Like here you can see that the image name is min.js server, right? And the tag is 1.0. But in order to push this to artifact repository, we need to write it in a specific format, and that format is source name. So that is the source image. We need to mention the source image whenever we want to retag an image. So the command is docker tags and the source image, which I will showcase you in a second. The location for the uh, artifact hub repository. So in our case, if you go over here, you can see that the location is Asia-South 1, right? So that is the location of the data center or the region where the artifact is going to reside or the image is going to reside. So please select that. And the next format is docker.pkg.deb. And then you also need to provide the project ID. Likewise, you also need to provide the repository, and then you need to finally provide the image with a specific tag, right? So this is the format that Google Cloud requires you to have whenever you want to push it into the artifact repository. And luckily for us, in order to make that process a bit easier, we can copy it directly from here. So if I copy this, it will give me that specific format that is required. So I can go back to my terminal. Let me pull up my terminal again. And now I can use the docker tag command again. So the source image is this one. That is the image that I named. So please uh, write the image name, whatever you are using to create your image on your own PC. This might be different if you are used on the image name. And then the tag 1.0. So this is actually the source image name, right, with the specific tag. But the format that is required. So let me copy that again and then bring the terminal back. And this is the format that I mentioned. So Asia-South 1, that's the location, docker.pkg.deb, the name of the project. So this is the project ID, and then the repository name. And then finally, I can give the image name, right? So if you go back to the Notion page, you can see that we can give our own image name using the slash and the image tag, right? So I'll do that. I'll do the same thing over here. So now, after this slash, I will copy whatever we have over here in the source as the US name. So now, so this was same as earlier. So we just added a prefix with all the requirements that Google Cloud has asked. So let me go ahead and retag that. Now, if I do Docker images again, you can see that You can see that we have a new image, and now it is properly tagged with the format that we need, right? So this is the new image, and it is in the format that Google Cloud asks. So now with this set, I can clear, sorry, clear. Let me list the images once again. And now I can use the Docker push command to push this to the repository, right? So let me just copy the image over here. Okay, so I have copied the image. Please remember that we also have the version tag over here. So this is the tag that we use. So once I do this, this will now try to push the images to the repository that we just created. So you can see that it is pushing the layers of the image as we described in the Docker file to the Google Artifact repository. So once this is done, we should be able to see our image in the Google Cloud repository. So let me go ahead and do that. Let us wait for this to complete. In the meantime, if you have any questions, please feel free to ask me. As we are reaching toward the end of today's session, we will continue from what we have left tomorrow in the second part, and I hope to see you all over there. So you can see that the image is now successfully pushed. So if I now go back to the, just give me a second, let me open up the other window. If I now go back to the image and I click on refresh, you can see that we have the Node.js server image right over here, right? So it means that the image is successfully pushed to the container registry or the artifact registry. And you can see that the image name is right over here, the different uh, digest, the size of the image, and all those things you can get over right from here. So you can also get the pull command if you want to share this to any other colleagues or in your team, then you can get the Docker pull command, which will pull the images in their own machine, but we will not be needing that. So we have the image for the server, right? So that is all that we have done till now. So before I leave you off, I just want to show you what we are going to do tomorrow. So right now, if you remember, if we go back to VS Code, we created the Docker image for our server, right? So we saw the Docker files for both a client, which is the Angular application, and the server, which is a Node.js server. So we created a Docker image for our server, that is the Node.js application. And when we authenticated our CLI with the Google Artifact Registry, we created a repository over there, and then we pushed this image to the Google Artifact repository. But you might be wondering why we have not done the same to the client as well, right? Because the client needs some specific URL for the server, because the client needs to communicate with the server where it is deployed, right? So we will tomorrow deploy the server first. We'll get the URL once we deploy the server, and then we will put the URL from the server in the client. We'll configure that, and then we'll build the image and push it to the artifact repository, and finally we'll run the client as well. So because we need the deployed URL for our server that needs to be configured in our client. So we are holding off pushing the image for the client for today, but tomorrow we'll be doing that. And also remember that our server needs a MongoDB tier 1 database, right? So we'll also be seeing how we can deploy a MongoDB instance for our Node.js application and how we can configure that in the server. And we will deploy MongoDB, uh, we will deploy first the MongoDB, and then we will configure the server. We will deploy the server then, and then once we deploy the server, we'll get the URL, configure it to the client. We will build the image, push it to the artifact repository, and finally set that off to run as well. And towards the end of tomorrow, we'll also see how we can push all of this code to GitHub and set up automatic deployments as well. So I guess that was it. For the slides and the demo today. So we saw about different Docker commands and all those things. So I hope that was very fruitful for you all, and you all learned about the basics of Docker, how you can build Docker images for your application. You also saw some of the sample Docker files for other uh, technologies, and then we went to Google Cloud, created the artifact repository, and then pushed it to the artifact repository, right? And I really want to thank you all for being here. Please feel free to ask me any questions. I can see already some of the questions in the chat. I will make sure that I answer that question before I end this stream. But if you are building a larger project this month, if you are working on any of the project this month, in the December, uh, it's the time of festival, and also our hackathon for the entire month is running. So you please go ahead and deploy or submit our project over there as well. I want to show you all how you can do that. So give me a second, and this is the link that you all can follow. So if you have not already registered for the month-long hackathon, please make sure that you can still register for it. So make sure that you go ahead and register for the event. And I have mentioned the link right over here as well. So you can see that we have our tons of prize such as best use of Redis Cloud, Hedera, Streamlit, MATLAB, Auth0, Flow, TypeI, Circle, and even one for the most innovative startup idea, which is sponsored by Google Cloud themselves. So make sure that you join the hackathon and then submit your project uh, in time, because you get a lot of amazing chance to win of the amazing prize as well. The deadline is January 4, sorry, the January 1st. So that is the end of this year and the start of the next one. So that is the end. So make sure that you go ahead and submit a project. If you have any question, feel free to ask that in the MLS Discord server, where you can find other people working on similar projects as well. Make sure that if you have a team, submit it in a team. If even if you don't, then you can submit solo as well, but we would highly encourage you to submit it in a team. So that was for the month-long hackathon. And before I wrap everything up, I already talked about the awesome prizes that you can gain at our month-long hackathon. So thank you everyone for being in this demo. So now is time for any questions, and we'll wrap things up. Uh, Thanks over there, Stoic. I'm super glad that this session was fruitful and you learned something. Uh, okay, let me get your first question. Will the stream be saved on Teaser? Yes, answer is yes. And definitely you can get the recording right after the stream on Twitch as well as on YouTube. So our sessions are recorded both on Twitch and YouTube, and you will be able to see the recording over from there. Please also make sure that you bookmark uh, the link for the resources that I showcased you all earlier, because that contains everything that you need to know to follow along. Uh, Oh, okay. That is a great question, Stoic. And yes, that is not a default feature for a Mac terminal. That is that is a feature of a tool called Fig, F-I-Z. I can provide you a link for that. But I believe the auto completion feature is only available for the Mac operating system as of now. Fig, you can install it on Windows as well as Linux, but uh, the autocomplete feature and all the suggested list and those things are there for the Fig autocomplete for back, I believe. This is the link of the tool that I used for that autocomplete. If you're using Linux or Windows subsystem for Linux, if you're using Windows and trying to use the Linux, there are other tools such as JetSS autocomplete and JetSS auto suggestion. So those are the other open source tools that you can use to get a similar kind of result, but the one that I'm using is Fig. Okay, I hope that answers your question. The next one, can I read my fellowship application? I have already submitted it. Real Legend, I believe that is a question for our fellowship team to answer. I believe most likely the answer would be no, but I do not want to assure you that, since I am from the coaches division. I do not know the answer for your question right away, but there is a dedicated Ask Fellowship channel in our MLS Discord server, and I would encourage you to ask your questions over there. You could also email at fellowship@mls.io to get your doubt clear. Cool. Thanks. Uh, there is one more question. I worked on a project during All In Hackathon, but I was not able to submit. So can I finish it? Yep, definitely. So if you were not able to submit a project during All In Hackathon, then you are more than welcome to submit it in the month-long hackathon. And there are a lot of other prizes as well. So cool. Cool. Thank you, everyone. Thank you, the power the tire. I am not sure if I pronounced you correctly, but thanks again for joining you all. I will see you about the same time tomorrow. So it's in the same time tomorrow, 6:30 a.m. Eastern time, and the 6 p.m. Indian Standard Time if you are from the APAC South APAC zone or from the North America. So make sure that you all register for the part two. So for that pattern, let me just quickly provide you all the link to register for part two as well, and that will give you all the reminder for it. Give me a second. I'll do that. Yep. So please make sure that you go ahead and register for the part two as well. And then I will see you over there tomorrow. Bye bye. Have a great day. Bye bye, everyone.